Alright, so now is the best time. We're going to do some worksheet of some example style question. These are exam style questions, alright? But we're going to go in levels. We're going to start from the easiest question that you get in computations of complex number. Then we're going to work up to the hardest question. So here we have Z1 is 2 plus 4i. And Z2 is equal to 3 plus 5i. And part 1 says we're supposed to evaluate Z1 over Z2 star. And number 2, oh, that's the only thing it asks for. So we need to work out Z1 over Z2 star. Now remember, Z2 star means conjugate. The star means conjugate. Always remember star. If it's a star, Z star, or if it's a Z bar, or it's a Z dot, all of those mean conjugate. Alright, so we need to work out Z1 over Z2 star. If Z2 is 3 plus 5i, then Z2 star is going to be 3 minus 5i. To find the conjugate, all we do is any sign that is in front of the imaginary part, we negate that sign. That's all. And so Z1 over Z2 star is going to be equal to 2 plus 4i divided by 3 minus 5i. Now what do we do next? When we get to this part, we multiply by the conjugate of the denominator. So multiply by 3 plus 5i. So we're multiplying just as we would, alright, with regular multiplication. So we'll put a bracket, put our brackets. It's going to be 2 times 3. 2 times 3 is 6. Plus 2 times 5i is 10i. 4i times 3i, that's then 12i. And then 4i times 5i, 4 times 5 is 20. I times I is I squared, so that's 20i squared. But then what is I squared? Bear in mind that I squared is negative 1. Always remember I squared is negative 1. Now in the denominator is going to become the difference of 2 squared, that's 3 squared minus 5i squared. Alright? So this is going to simplify to become I squared is minus 1, so this is negative 20. 6 minus 20 is negative 14. 6 minus 20 is negative 14. 10i plus 12i, that's 22i, over 3 squared is 9. Now 5i squared is 25i squared. Alright, so 5i squared is 25i squared. But I squared is negative 1. So this is really negative 25. But then you have a minus sign in front of it, so it's minus 25. Minus and minus become plus. Since this becomes plus, it works out to be minus 14 plus 22i over minus and minus is plus, this is 36. That's your answer. Now you could go ahead and simplify it. So just you like to write it as one final thing. You want to simplify answer per take and say Z1 over Z2 star is negative 14 over 36 plus 22 over 36i. And you can simplify because you can divide numerator and denominator by 2. Divide numerator and denominator by 2. You could, but can't bother do that. That would be the answer. Alright? Lovely. So that's a typical exam style question. That this question was testing our knowledge of conjugates, it tested our knowledge of dividing, and it tested our knowledge of also multiplication, because you had to do some multiplying. Alright, so that's what that question tested. Let's look at another example. Alright, so number 2, it says find the values of, we have I to the 12, we have I to the 15, we have 4 over I to the 8, and we have 5 over I to the 20. We need to find the value of those. How are we going to find the value of those? Well, remember from the cartoon animation video, remember from that video, what did we say? I is the square root of -1. If you square that, I square is -1. Yeah? When you square, the square root gonna go away. Then I cube is equal to I squared times I, but I squared is -1. So I cube is minus I, and then I to the 4 is equal to, I to the 4 is what? I to the 4 is going to be I squared times I squared. But I squared is -1. -1 times -1 is 1. So I to the 4 is 1. Once you remember these 4, 1, 2, 3, 4. You're good. So look at this. I to the 12 is what? I to the 12 is I to the 4 times I to the 4 times I to the 4. By laws of indices. Beautiful. So this is just 1 times 1 times 1. 1 times 1 times 1 times 1 is 1. Now we need I to the 15. Now look at that. I to the 12 is what? 1. So this is now I to the 12 times I cube. I12 is 1 times I cube. But I cube is what? Minus I. So this is 1 times minus I, which is minus I. Easy. Now we need 4 over I to the 8. So this is just 4 over I to the 8 is I to the 4 times I to the 4. So that's I to the 4 is 1. 1 times 1 is 1. 4 over 1, that's just 4. 5 over I to the 20. Now we already know I to the 8 and I to the 12. So this is 5 over I to the 8 times I to the 12. But I to the 8 and I to the 12 are both 1. This is just 5 over 1, which is 5. That was an easy question. Just to find those values. Easy. I to the 12 is 1.
Bruh.
I to the 15 minus I.
Hey!
4 over I to the 8, 4. 5 over I to the 20, 5. We just need to remember that. Easy. Nice. Alright, now this question says, given z squared is equal to minus 5 plus 12i, find the complex number z. Alright, so this says given z squared is equal to minus 5 plus 12i, find the complex number z. Now, when you square root a complex number, the result is complex. When you square a complex number, the result is complex. Alright? It's going to be complex. So look at this. Z squared is minus 5 plus 12i. So now z have to be some complex number. So we can say, let z be equal to a plus bi. If we call z a plus bi, then that implies that z squared would be a plus bi all squared. Yeah? But if we expand this, then z squared is equal to first term square, a squared, plus twice the product of the two, 2abi, plus second term square, which is plus bi squared. But bi squared is b squared I squared. This part right here so is b squared I squared. So that's going to be z squared is equal to a squared. This part is plus b squared I squared plus 2abi. But I squared is negative 1. So z squared is equal to a squared minus b squared plus 2abi. That's going to be z squared. Now, if z squared is this and z squared is this, so look at that. Z squared is a squared minus b squared plus 2abi, and z squared is minus 5 plus 12i. So we have two expressions for z squared. So we just need to solve for a and b. Once we solve for a and b, then we'll get the complex number z. So come to that. We're just going to make a little bit of space. So we said that z is a plus bi. And from that, we garner that z squared is equal to a squared minus b squared plus 2abi. And also z squared is minus 5 plus 12i. So let's start by equating our real parts. If two complex numbers are equal, then their real parts must be equal. If two complex numbers are equal, then their real parts must be equal. So that implies that a squared minus b squared must be equal to negative 5. A squared minus b squared must be equal to negative 5. What else do we know? A squared minus b squared equal negative 5. And from the imaginary part, 2ab is 12. 2ab equal 12. Cool. Alright? So these two, nice. Lovely, lovely, lovely. A squared minus b squared is negative 5. 2ab equal 12. Lovely. From these two right here, we're going to solve for a and b. Look at the second equation, right? If we divide both sides by, let's say, 2a, we get b is 12 over 2a. 12 over 2a is 6 over a. Alright? So why not sub? Let's sub b equal 6 over, let me write sub better. Let's sub b equals 6 over a into the first equation. Alright? So that means that the first equation going to become a squared minus b is 6 over a. That's 6 over a squared equal negative 5. Expand out the square. This becomes a squared minus 6 squared is 36 over a squared equal to negative 5. Then we can multiply through by a squared. When we multiply through by a squared, we get a to the 4 minus 36 is equal to negative 5a squared. So now we can bring over the 5a squared over here to get, therefore, this is a to the 4 plus 5a squared minus 36 equals 0. Beautiful. So that is what we have. We have a to the 4 plus 5a squared minus 36 equals 0. Absolutely fantastic. Once we get to this stage now, we can factorize, but we can realize this is a hidden quadratic. So let m be equal to a squared. Don't use my letter, use another letter. If we call a squared m, this is really m squared plus 5m minus 36 equals 0. So we can factorize m. To factorize 36, it has to be 9 and 4. This is saying signs are different. The bigger number get the positive, plus here, minus here. So m equal 4, m equal negative 9. But m is what? A squared. So therefore, a squared is the one that equal to 4. Or a squared is equal to negative 9. Now we know this part can't true, right? A square can't be negative 9. A square cannot be negative 9. This one, not valid. That's not valid because A must be a real number. The real part can't have an imaginary number in it. So A square is equal to 4. And so therefore A is equal to plus or minus 2. A is plus or minus 2. So we're going to clear this off and continue. So we get that, remember we get A is plus or minus 2, this is A, but remember B is 6 over A. So B is plus or minus, when A is positive 2, 6 over 2 is 3, when A is minus 2, B is minus 3. That's it. And so the complex number Z, therefore Z is going to be equal to, what is Z going to be equal to? A plus BI. So Z is, let's start with a positive, it is 2 plus 3i. What about when A is negative? Or Z is equal to minus 2 minus 3i. That's it. That's the complex number Z. Nice. So you can test it out. What I'd like you to do is do your check. Alright? Do your check. How do you check? Check by seeing if Z squared, when you expand 2 plus 3i squared, check and see if you get negative 5 plus 12i. Do your check, alright? First terms, yeah, it's going to be it. But you can check it out, alright? And that's how we do this exam style question here. It's very easy, finding the square root of a complex number. Nice. Alright, another question, it gives us this, a different style, and it says Z is 1 plus 3i over 1 minus 2i, and it says to find Z squared and Z minus 1 over Z. So we need to find Z squared and Z minus 1 over Z. Alright? Cool. So let's go ahead and do this. To find Z squared, this is Z, so know that Z squared is going to be 1 plus 3i over 1 minus 2i all square, right? Now, why would I want to square this complex number? That's crazy, right? That's crazy. There's two ways we can work this out. We can multiply it by itself and then simplify it, or we can rationalize it. We can rationalize it first and then square it. We're going to do it method 1 first. Alright? It's always good to do things two-way. So let's call this method 1. First, we're going to multiply it by the conjugate of Z. So multiply by 1 plus 2i over 1 plus 2i. Alright, beautiful. So multiply by the conjugate. Alright. 1 times 1 is 1. 1 times 2i is 2i. 3i times 1 is 3i. 3i times 2i, that is 6i squared. Divided by, now, the denominator becomes the difference of 2 squared. So we're going to have 1 minus 2i, and it's 1 squared minus 2i squared. That's the difference of 2 squared. Now 1 plus 6i squared, I squared is negative 1, so it is 1 minus 6. 1 minus 6 is negative 5. That's negative 5. Plus 2i plus 3i is 5i over, now 2i all squared, that's going to be 2 squared is 4, I squared is negative 1, so inside here is negative 4. This is 1 minus negative 4. But minus and minus become plus. So this is over 5. What do we do next? We can divide numerator and the denominator by 5 to get, this is now minus 1 plus I. Alright? So that's all that Z is working out to be. So Z worked out to be minus 1 plus I. Look how that's easy now. Easy. So now we can say Z squared is just minus 1 plus I all squared. That's going to be first term squared, which is 1, plus twice the product of the 2. 2 times minus 1 times I, plus second term square, which is I squared. Beautiful. I squared is what? -1. -1 plus 1 is what? 0. So this becomes 0. Then we have 2 times -1 times I. That's just -2i. So this works out to be -2i. That's z squared. So the first part that wanted z squared, just to put the answer up here, z squared worked out to be -2i. That's part 1. Easy. Now we want to see method 2, right? Let's have a look at method 2. Now whenever you have a complex number z, so z is equal to 1 plus 3i over 1 minus 2i. So we have a complex number and we need to find the square of it. The square of z squared is equal to z times z. So you can multiply it by itself. 1 plus 3i over 1 minus 2i. When you multiply a complex number by itself, let's multiply across the numerators. This is just going to become, by the way, we can see that, look at this as 1 plus 3i all square over 1 minus 2i all square. So this is going to be now equal to first term square, which is 1, plus twice the product of the 2, that's 6i, plus second term square, 3i squared, that's 9i squared, over first term square is 1, minus twice the product of the 2, minus 4i, plus second term square, 2i squared is 4i squared. Okay, cool. Now minus I squared is -1, 9 times -1 is -9, 1 minus 9 is -8. This is -8 plus 6i over 4i squared is 4, 1 minus 4 is -3. So that's -3 minus 4i in the denominator. So far we're getting z squared is equal to -8 plus 6i over -3 minus 4i. Now we need to multiply by the conjugate, right? Yeah, let's multiply by the conjugate. Multiplying by the conjugate is -3 plus 4i over -3 plus 4i. Beautiful. So now we'll go ahead and multiply across the numerators. -3 times -8, that's plus 24, plus -3 times 6 over -3 times 8, -3 times 6, that is -18i. Then we'll go 4i times 8, 4 times 8 is 32, so that's -32i. And then 4 times 6 is 24, so that's now plus 24i squared. Over, multiplying the denominators becomes the difference of 2 squared, so that's -3 squared minus 4i squared. Simplifying, what we're going to get is, look at that, 24 plus 24i squared. 24i squared is -24. 24 minus 24 is 0. So this becomes 0. Then minus 18 minus 32, that's minus 50i over -3 squared is 9. Minus 4i squared is 16i squared. So this is minus 16, right? 4i squared is -16 because I squared is -1. Minus and minus become plus. So this is -50i over minus and minus is plus, that's 25. -50 over 25 is 2. This is -2i. Just like we got up there, z squared is -2i. So we'll show the method 1, or we'll show the method 2. So any way you prefer to do it, remember, you can always square the number by multiplying it by itself, or you can rationalize and then square it. Whichever way you prefer to do, perfectly fine. My preference you rationalize, and then you square. You can never go wrong by rationalizing. No, you can go wrong by multiplying across, because it's just difficult when you're going to have to multiply across, and then it's just too much work, right? Your brain just get tired. But do it the first way, and less steps, less work. Now let's do the next part, z minus 1 over z. Alright, so we need to work out z minus 1 over z. Now I remember we got something for z. When we rationalize, what did we get for z again? It's always best when rationalize. I think we got minus 1 plus I. Alright, that's what we got when we rationalize z. Alright, so this is equal to this. Z is equal to this. Remember, that's what we got from part 1. This is what we got from part 1. Alright, so therefore if we want z minus 1 over z, so z minus 1 over z, they're just asking us to find minus 1 plus I minus 1 over minus 1 plus I. Okay, so this is what we need to work out. Now this part now, we need to find what is 1 over z part, right? What is 1 over z? No worries. So let's work it out here. Now, 1 over z is equal to 1 over minus 1 plus I, and multiply it by the conjugate, which is minus 1 minus I. And anything you do to the numerator, you do to the denominator. Remember, the conjugate is just this sign you change. In front of the plus, that becomes minus. Beautiful. So now that we do that now, 1 over z, we can multiply their numerators across. 1 times minus 1 is minus 1. 1 times minus I, that's minus I, over minus 1. The denominator becomes the difference of 2 squared. So this becomes minus 1 squared minus I squared. Now minus 1 squared is 1, and I squared is negative 1, so this becomes 1 plus 1. 1 plus 1 is 2. So this becomes minus 1 minus I over 2. Alright, so that's z, that's 1 over z. 1 over z is minus 1 minus I over 2. Alright? So now that we've gotten that out of the way, now we can work out z minus 1 over z. This is equal to, so we don't want it to look confusing, so this is 1 over z. Just going to write it down. 1 over z is minus 1 minus I over 2. We're going to put it in a box right here, so we can continue the question. So now we can continue and say this is now minus 1 plus I, yeah? Minus, this part now it's minus 1 minus I over 2. Now anytime you're dealing with fractions, I love when you change everything to a fraction. So this is equal to, you see this part, change it to a fraction too. We can put 2 over 2 in bracket, minus 1 plus I, and then expanding the minus inside. When we expand in the minus and the minus going to make this become plus 1 over 2. Minus and minus make this become plus 1 over 2 times I. All we did is expanding the minus. Now when we change this part to 2 over 2, this is now just saying minus 2 over 2, and this part is now saying plus 2 over 2I plus a half I. Now go back to grade 8. How do we add? We always add like terms. The like terms are the real number part. Minus 2 over 2 plus a half. 1 minus 2 is negative 1, so this is negative a half. And then 2 over 2I plus 1 over 2I. 2 plus 1 is 3, so that's plus 3 over 2I. Then we can factor out a half. I will leave it as minus 1 plus 3I. So it's a half of minus 1 plus 3I. And that is how we work out the z minus 1 over z. Beautiful. You want person like this? And you smile. You just say, nice. That's beautiful. Alright? That's how we take care of this question.